Find the area of the region bounded by the following curves. Set up your integrals with respect to y, which means these guys have to be solved for x. Well, you're solved for x, you're not. What I'll do is I'll do two things at the same time. I'll add x and subtract y, and by doing that, you become x equals 2 minus y. No harm, no foul. Okay, then we also have y equals 0. That's going to serve as a limit of integration. Now, what we also don't have is the other limit of integration. So the way I'm going to find my limits of integration is I'm going to set these guys equal to each other. Okay, I'm going to say y equals 2 minus y. If I add 2 to both, if I add y to both sides, that becomes 2y equals 2. Divide both sides by 2, and y equals 1. So my limits of integration are going to be 0 and 1. So we set up our integral. All right, and now the general equation for this is from a to b, the integral from limits of integration a to b of f of y minus g of y. Now normally I hyper-focus on which one of these is the higher graph, but I'm not going to do that here. If I end up with a negative area, I'm just going to make sure I turn it positive. We'll see what happens. I'm not scared of anything. But what I do have is I have the fact that my limits are now 0 and 1. That was a close one. 0 and 1. I'll call f of y, I don't know, x. Not x, y. Minus 2 minus y, close it, dy. Let's simplify that a little bit. Okay, y minus 2 plus y dy is going to be 2y minus 2 dy. Now let's integrate that. The integral of 2y is just y squared, and the integral of negative 2 is negative 2y. Your limits of integration are still 0 and 1. So let's plug stuff in. We get 1 squared minus 2 times 1, close it, minus 0 squared, how nice, minus 2 times 0. That gives us here 1 minus 2 minus nothing. 1 minus 2 is negative 1. Now again, I was worried that this would happen. I guessed wrong by choosing y as f of y. No big deal. All we have to do is flip-flop it, and we get 1. And so the answer is A, 1 square unit. Baby.